don't know if you quite got how awesome that is, that what I just did. So because of the way I set up my spreadsheet with cell references and all of that, what I could do is I could copy and paste pretty much the top block, everything that had like x1, p hat, and all that jazz, and the test statistic, because that stuff doesn't really change from problem to problem. I could bring it over here, I could paste it, and then all I had to do was change the numbers to what my particular problem is. So 363, 1100, 396, 1100, and everything just automatically changed to match it. Beautiful. Don't want to do step 4 because this is a two-tailed test, so I'm going to have to go in here and say not equal, right? So kind of get the not equal symbol in there. And then I'm going to have to change how I do my critical values for step 4, which is where we're at right now, step 4. So I'm going to be doing the classical method first. That means I'm going to need a critical value. Actually, I'm going to need 2 of them. But which is z alpha, oof, you can't see that, alpha divided by 2. Okay. Okay. So new Excel, you can just do norm dot dist, and then you want alpha, oh, I'm so sorry, norm dot inverse. Ooh, losing my mind. All right, alpha divided by 2, right? Because it's z alpha over 2, comma, the mean is 0, standard deviation is 1. There's the negative one. And then the other one, so the other crit value would be equal to negative of that. Okay. If you're doing old Excel, it's no different. It's just norm dist, or gosh, I keep doing that, norm inverse, thank you, norm INV. Again, alpha divided by 2, comma 0, comma 1. Okay. There's more decimal places there, you just can't see it. And then the other one would be like that. Okay, so step 4, classical method's done. What about the p-value? The p-value is equal to norm, now it's norm dot dist, norm dot dist, there we go, test statistic, comma 0, comma 1, comma true. And it works out for us great that this is a negative test statistic. If this was a positive test statistic, you'd have to do what we did in the right-tailed example, number 15, i.e. either make it negative or do the opposite, do negative norm dist. Sorry, norm dist of that value right there. Okay, so you'd have to make it negative. That's really the only option you've got. All right, so there's your p-value right there. If you're working old Excel, that's norm, oh my gosh, I can't spell, norm dist, that value right there, comma 0, comma 1, comma true. And again, if it wasn't negative, your test statistic wasn't negative, you could do 1 minus, or you could do the negative of that test statistic to make it negative. Like if it was positive 1.48, you'd say negative cell E11, and that would make it happen. Okay, so we've got our p-values now. Notice we are totally going to not reject. So we do not reject H0. Why? Well, because if you're doing the classical method, because your test statistic Z0, which is equal to negative 1.48, is not lower than negative 1.96 or higher than positive 1.96. In other words, it's not in the critical region. Or you can say the p-value, p, which is equal to 0.0694, is greater than alpha, which was 0.05. And yet again, let's take a gander at StatCrunch. Stat proportions to sample. We have a summary here. Okay, so let me grab those numbers. So it's 363, 1100, 396, 1100, and it's a two-tailed test, which is what we want. Calculate, and there we go. Positive 0.139. Oh, I'm a moron. I forgot to multiply by 2. See? That's why you do it. You double check yourself. Because it's a two-tailed test, you need 2 times this norm dist. I'm an idiot. 2 times. That's why StatCrunch is so dang handy.